Hello and welcome back to compiler programming. Today I want to improve the Linux support in the compiler. So right now, if I want to interact with the kernel in some way, I have to do it through libc, which is certainly one way to do it, and it's good that we are able to. I think maybe eventually I will support BSD, and there it is expected to be the only way to communicate with the kernel, like you're only supposed to ever call it through libc in sort of the same way as on Windows you call the kernel through the special APIs in NTDLL, I think, or in kernel 32 DLL. So yeah, basically some systems that this is how you do it, but Linux has a stable syscall setup. So if you want absolutely no dependencies, you can do that. You just need to be able to make a syscall. So if you're not familiar with how that works, essentially you are just setting up some registers and executing a syscall instruction. So we can take a look at that first. I found this reader that is dark theme, so hopefully it is slightly better to watch than white PDFs. So we are looking for syscall. Fast system call. Yes, that is exactly what we want to do. So this is an instruction like any other. You just do opcode 0f05 apparently, and it will execute a syscall. Blah blah blah. So it loads the instruction pointer and saves address in RCX. So interesting, it doesn't push down the stack, instead it saves it into RCX. Saves R flags. Okay, I don't think we really need to care much about what exactly happens here, because the actual calling convention is described somewhere else. From the Intel instruction manual, for now we are only interested in this opcode, because that's what we need to go to instruction.c, and we will just put it somewhere. I think here it's a good place, next to ret and int3, and we will just say syscall, and this would be 0xf005. Is that correct? It's 0f05, 0f05, I believe. Yeah, implementation should correctly handle that. It doesn't have any operands, as you can see, NA, so no operands here, and there is no operand encoding because of that. So this should be the right definition. Let's try to compile that we know that it actually works, and it seems to go just fine. Now, the second question that we need to figure out is how to deal with it on the level of the syntax, and I'm still not exactly sure how I want to handle calling conventions. I obviously want to eventually allow people to describe a calling convention inside of their user space code, but I think until I'm finished with all the existing calling conventions, I'm not sure what it would be the good abstractions, because they are very different from each other and they require kind of sort of different things from the implementation. So I'm still deciding, and the best way to help you with the decision is just to learn more about the kinds of things that exist out there and go from there. So let's do it this way. We want a syscall, and I think the way I'm going to implement it is exactly the same way as this external works. So I'll just have a syscall here, and instead of 2 strings, it will just accept a number. So the number of the syscall that you want to do. I actually have no idea what is the list of all syscalls, so bear with me, it will be bright for a second, because I need to search for something like Linux syscall table. Yes. That sounds good. We have 32-bit table. Okay, click dark. Yes, we can even put it dark. And we have read, write, open, close. So write sounds like a great syscall. Oh, it's right again. There is implementation, but I want to know how to deal with it. So what goes where? So Linux, write syscall example, maybe? How to do, that's not exactly what I'm interested in. So I guess I can do man write or something, man to write. Here's my WSL, man to write. I'm not a Linux person, as you can see. I spent most of my life working on either macOS or Windows, so I don't know much about Linux. And on macOS, I never really did kernel stuff. So, and you're also not really supposed to do syscalls on Mac because they are unstable between versions, same as they are on Windows. But I think Windows will have even worse time if you try to do syscalls. But at least on Mac you can do them. Just it's a bit tricky if you want to support multiple versions of operating system. Anyhow, so it wants a file descriptor, and it wants a buffer, and it wants a count. Okay, that seems pretty reasonable to me. So let's do that. And it is syscall. I already forgot what is. Does it even say what is the syscall number of right here? This is not very useful for what I'm doing, so it's gonna be bright again for a second. And we are going back. So right is 1. That's fine. That's what I'm gonna be using then. Let me get back to the editor. We still want stdio file number, I think, because that is like this write is just a wrapper around the syscall anyway, and I guess we're gonna be fine. Yeah, so the signature is exactly the same. The only difference is we need to pass in somehow the sys write, which is also happens to be 1 over here. Sys write 1, and I would expect to look something like that. That seems pretty reasonable convention to me. Now, the tricky part is I think it returns an S32. So the way syscalls work on Linux, we can see it in this document. I will actually link both. I think I will link this document in the description somewhere. So this is System 5 ABI, as you can see, and there is a section here on so if we search for syscall over here, yeah, so there is a section on Linux kernel conventions, and there is a calling convention. They explicitly actually say that you're supposed to use a C library, but you know, it can't stop me, and I know at least as long as Linus Torvalds is in charge of Linux, they will maintain their compatibility on this level. I know he's very vocal about that, and I completely agree that this is a great thing to have. It's kind of sad that you can't do it on other operating systems. But yeah, so we can ignore the C part. That already works anyway, and we're going to focus on this calling convention. So there is a warning here about a red zone. I have not really talked about red zone in any of my videos. And since I'm not using it, I'm just gonna ignore it. If you would like me to explain a bit more this kind of stuff and how stack is set up, I can do that. Maybe leave a comment in the video or something. I might do more videos about all of this. But yeah, this whole stack thing is not relevant to us, but this stuff is. So if we read what it says here, that it follows the same calling convention as user level applications, except for these changes. So what is the calling convention for user level applications? Well, I have it implemented here, at least the majority of it. So this file is like 800 lines long, and out of those 800 lines, 550 lines is basically the Linux version, and the other 250 is the Windows one. So Linux calling convention is quite complicated, but I tried to make this file quite readable. So these numbers, they actually correspond with sections in this document that describes the Linux calling convention or System5 calling convention. So you can more or less follow the code and the document at the same time, and hopefully it will help understand what they actually mean. There are a couple of to-dos here, but those to-dos are sort of not really interesting ones. The biggest hurdles are, I think, implemented, and this is specific to mass programming language. So if you implement something that has more traditional structs, you will not actually run into this. So long story short, we still need the same thing, and I'm kind of happy with the way I set up the code for calling convention, because here I have these lists of registers, and then so I can specify this list of registers, and then I can just run the generic algorithm of classification that is part of this document, and it will assign things to registers in the right way. Okay. Now, we sort of need to make a copy of a calling convention. So right now we have, as you can see, Windows, and we have System5, and now I want to have another one. So this would be calling convention x86-64 System5 syscall, and we're gonna add System5 syscall setup proc, I guess. And now we can take a look at what is the deal with the registers. Let me move it somewhere here. I think that should still be visible on the screen, and I can also look at it at the same time. So passing sequence RDI, RSI, RDX, RCX, R8, R9, that seems exactly the same as, no, that is for user applications. The kernel applications apparently use RSI, RDX, R10, why is it in the wrong order? That makes no sense. Oh no, I also missed the RDI. So we do want RDI. So we use RDI, RSI, RDX, R10, R8, and R9. I will keep it in the same order because to match the documentation, but this is kind of weird. Looks like they just did lexicographical sort, and 10 ended up before 8. Okay. So R8 and R9. The kernel destroys registers RCX and R11. So I will need to put C and R11 as volatile as well. So this is volatile register bit set. And the return is inside of register A. So this is just return. Okay, so this just describes to the compiler which registers need to be saved before we can make a syscall. Otherwise, the kernel will mess with the registers, and when we get back from a syscall, we will lose some information. So this is important for the compiler to know what registers are going to be destroyed. Okay. The number of the syscall has to be passed in register X. That is fine, I guess. We can do that, but that will be later on. And then returning for syscall array X contains and only values of class integer or class memory are passed to the kernel. Okay. Good. So I think here we are done. But now we need to go into here. And we can do static function call setup, call convention setup proc, blah, blah, blah. We get the function and we can start doing. So I think I will just grab what the user length code does for this call convention, and then we will go from there. Okay, so this is the return thingy. For return, we don't need to classify anything. The only thing that we need to do here is, I guess, something along these lines. So color, return value, can do like this. Color return value is callee return value, and they're both going to be register A. That's fine. And in here, for now, I will do assert descriptor S32 and fix me provide user error. And this is one of the things I mentioned that I don't know what should be the interface to syscall, because as you can see till now, this couldn't really fail, but now it can fail because you always expect to return an error, and that means that the descriptor here needs to be a particular type. Otherwise, that's incorrect. But maybe that should be handled at some other point. I don't know. Or should it be handled earlier? Let's see. So we expect it to be S32. It goes into register R. Everything seems to be fine, and we don't need to do any of that. We don't need any classification of the... Well, we can sort of do it in a slightly nicer way that is more common with how we do other stuff. And yeah, that's not storage indirect, actually. That is storage register for descriptor, and we saying that this is a descriptor S32 and it's register A. Okay. Something along these lines. First of all, does that even build? Right, we need to put this here and this here, I guess. And I need to flip the arguments. Great. Okay, I'm missing a forward declaration in here. That is perfectly fine. I can do that. Okay, that built, but that is not all we need to do. So this just takes care of the return value, again, which is described here, that it is inside arrayx, and the whole minus error is I'm not gonna handle it right now. I think we'll see how it goes. I'm not so interested in errors at the moment. I might even leave it as sort of a raw error that you will get. Okay, now the general registers. This is what we did in here as well. So I can just more or less copy this, and then we can repeat this in here. So di, again si, dx, and then r10, r8, and r9. That's great. You do not have any vector registers, so this is I'm not sure if this works. Can I have like a 0 length array? I don't think I can. So that's gonna be awkward. Yeah. Can I do like this? That sucks. Well, I guess I will just say that this is 0, and then where does this go? Yeah, in here. So this is 0 and 0. Maybe I can just do 0 like this and remove registers from here. Okay, so di, si, d, r10, r8, r9. Great. Destroy registers is already taken care of. The RAX passing, I think I will take care of that in a different place where we actually call this function. I'm not sure exactly again how to handle it best, so I'm just gonna do what seems the easiest right now, and will make another comment saying here to do consider if actual syscall number should be handled here. But I think not. We'll see how it goes. Okay, so let's look at what's happening. We are creating a special state that sort of is necessary to keep track which registers we already assigned an argument to. This is not something that happens with the calling convention of syscall, so we don't need that. And capacity, we don't need that either. Okay, so how do we want to deal with it? There is this thing about system calls unlimited to 6 arguments, and no argument is passed directly on the stack. So making that work can be tricky indeed. So okay, we are skipping this stuff. So I think we need to assert. This is something custom that Mass has, where you can define an argument. It's not really an argument really, but it's a static value in the argument list that is available in the function. So it's sort of kind of namespacey thing in a sense, but that's used for overloading. But it's not something that you can use in the syscall. So just in case of what I'm looking at is static puff. I'm not even sure if I have a test for it. I think I do somewhere. let me try to quickly find it. Yeah. So this is how it looks like. As you can see, I can have so this means an argument of type, and this means the argument of exactly that type, statically known as 32. So here we would end up with this as a preferable overload, and we will go into the thing. So the column convention thing here was just skipping over this kind of static argument because there is no reason to actually pass them in registers or on a stack, as we know at compile time what they should be. So yeah, they just disappear from the parameter list. They are there just for overloading. Okay, then we try to classify thing, and then there is this system5 adjust classification if no register available, and I think this is something that needs to change. So there are no vector index. So this is tricky because memory means, in a sense, two things. It can be an implicit reference, or it can be stack. And this is weird. This is really, very weird. No, because here memory is always Let me quickly search that because I did it a while ago and I might have already forgot a bit about how all of this works. I believe that if you end up with memory, you're always passing it on the stack. So this is kind of strange to me. It has class memory. Great, blah blah blah. One of the class memory. Yeah, if the class is memory, pass the argument on the stack. Okay. So now that doesn't really compute to me, because it says here system calls are limited to 6 arguments and no arguments is passed directly on the stack. And then there is the number 6, which means that you can have memory classes. That is weird, to be honest. I'm not sure exactly what they mean by that. I need to look into maybe GCC or something implementation of this stuff, but those two statements seem contradictory to me. But I'm pretty sure they know what they're doing, so I'm just misunderstanding this document. But I think I told before, this whole document, I just don't know how to read it because I constantly spend like days trying to understand exactly what they're trying to say here. So yeah. Anyway, we're just gonna ignore this, and for now, what I will do is I will just say that if classification what? So something like this. If classification is not integer, or we ran out of registers. Maybe it should be two separate things. So if it is not an integer, For now, again, assert. So fix me user error. And also, did you figure out how 6 item 6 can be understood together with the item 4? And while in user space memory class arguments are housed on the stack. So I'm just gonna make this thing, and yeah, I have no idea what's supposed to happen. Probably can do some godbolt stuff or stuff like this and try to figure that out. Maybe they just expect to turn memory things in references or something. No idea. Okay. For now, we'll just say unsupported system 5 argument class in a syscall. Okay. And then this line tests if we run out of registers. So I don't hardcode 6 here, but that 6 is implicit based on the fact that here, as you can see, we have 6 registers. So yeah, and this is where it goes. And here we say system 5 syscalls support no more than 6 arguments. And this is no longer necessary. Okay, and then we create this is just a record for the compiler to tell us where to put this argument into, and we are pushing it. That is fine. In a sense, we need to assert that stack size is 0. So stack offset, because we can even copy this, I guess. Okay, this should never happen. Okay, what did I screw up? That would be state registers, and then classification is dot here, not arrow. It's not called state, it's called registers. So I just need to again change dot to dot. Okay, so that builds, but it still doesn't do anything because the tricky part comes into play now. Like we have that test, right? We can focus on it, and we can do some sort of TDD style thing where we just try to run the test sh and see everything explode. Yeah, so it has no idea what variable syscall actually is. Let's look at how external implemented, because that is similar to what we're trying to do with syscall, and I believe external, yeah, it's actually implemented here. So I can replace this while I'm looking at it. Okay. So we have syscall, and that accepts. I'm not sure what is the size of the syscall variable. I guess it is still an S32. So I will say number, and then this is gonna be S32. I'm not sure that's correct, but let's see. And it will do a syscall, and then we will have number is number and return result, same as this thing. But we still need to create a syscall struct. So for that, we go to meta, we again go to external symbol. This is where we're handling this. We are doing syscall. We will have S32 number. So that should get us a bit closer to what we want. At least now this error should disappear, and the next error, or probably a crash, actually will happen. But let's see. Yeah, so this is what I would expect to happen. Now we just don't know what to do with this stuff. We can go to this thing, that's function 817, and this is our panic. We don't know what to do about this. Now, I need to think about where is this, where should we take care of this? I think we shouldn't actually do it here, but rather slightly earlier. Let me look at where we are figuring out the calling convention. Yeah. So this is a change that I would probably need to make before we can proceed, because right now it is assumed that whenever we have a function literal, the calling convention that is used for that function is the calling convention of the program. But that is not necessarily correct. We should attach the calling convention to the literal when we create it. Because as you can see now, for syscall it's different, and maybe later I will allow users to specify the calling convention that they want right in the literal as well in some different way. So let's make the change. The way I like to do this now is I will disable this test, and I will verify that the rest of the tests still pass, at least on Windows, everything is fine. And the rest of the tests passed on Linux we also will see in a second. And in the meantime, I will do this small refactoring. We need to go into parse function literal. This is a function that we worked a bit in the last video as well. You might want to check it out where I implement the generic arguments. And then in here, this is where we create a literal. So now we look into the definition of function literal. And in here we can add some fun stuff. So we could do like calling convention. I think I want to always specify it, I guess, maybe. The tricky part about this is that unlike in many programming languages, in Math, your function can be called at compile time and at runtime without any extra limitations. So in C++, you would have something like const expr where you have a limited functionality in there. But in here, if we look at any function, so for example, this is more or less a regular function. You just call it at compile time, and nothing. It just works. This is also a function that is called at compile time, but they're not different from each other. And the thing is, right now I'm running Math on x86 64 system, and the target architecture is also x64, so they will probably even have the same calling convention. But if I try to do cross compilation, where I try to compile for Linux while I'm on Windows, or other way around, which is something that actually does happen, then you cannot just assign a calling convention to a function and make it work by default in both systems, more or less. It's not exactly true, but if the user would expect that if you don't specify a calling convention, it would automatically be the right one. So in a sense, I can't just go here and say like calling convention is whatever, right? Or take it from here and just copy it from the program. That would be the wrong thing to do because we expect it to be automatic. But sometimes we do want to force it. So in those cases, we will put something here. So the way I'm gonna do that is I'm gonna say if body value descriptor is descriptor syscall, then I would do const syscall star. Syscall is storage. Let me find something that I can copy. Storage static. Yeah, this is what I want. Storage static C type. I take body value, storage, and then I say syscall. Then we actually no, I don't even need to undo this because I am not interested in actual number, I think, or am I? That is no, maybe I am. Maybe I am. Let's think about this. Okay. Right. So now if I know that we want to do a syscall, so if we found, let me go back to the test. So if we see a function whose body, this is like the header of the function and this is the body of the function, if the body defined to be a syscall, then I will end up in this branch and I can say that literal calling convention, and this is an interesting thing that to do, figure out how to handle this on Windows. So this is a bit awkward. I don't have a good story of target platform right now. It's not tracked anywhere, and this is certainly something I do need to do. So I'm just gonna do this as fix me. Okay. Literal calling convention is right here. For now, we're just trying to make that test pass, and then we'll see where it goes from there. Okay. And now actually want to replace the body of that function with something else. And that something else, what would it be? Well, essentially, I want to just execute a syscall. Not sure what would be the right way to go about that. I have inline machine code bytes, lazy proc. So push instructions builder, but that happens on a slightly different point in time, maybe. That is a good question of how do I go about that. Maybe I don't actually do this here, but I keep it like this, and we do make it work over here. Okay, but it wants a force exact, so let's go around here. Else if literal body descriptor is descriptor syscall, then we say nothing to do, and here we say if again, if it is a syscall, or nothing to do, but something like handled below. And here, if it is a syscall, then we do one thing. Otherwise, we are doing something else. So we cast it to syscall, and when we need to emit an instruction, which is now super easy in here, we don't actually want any of this to happen. I guess. I mean, this is fine. This will be no-op in a sense. You know what? That I think this is the wrong place to handle this, as much as I would think it is. Let me quickly think about that. Yeah, maybe that's not exactly how I want to handle all of that. So this is tricky, and I'm glad I got into this right now, because it seems that the abstractions that I created for handling functions and instances is not exactly matching very well with how syscalls are handled. So I know most other languages, if they for syscall they just do kind of wrapper functions, and then they do inline assembly to shuffle registers there and back again. But I think that's a bit awkward. I don't like to do that if I can avoid it. But at the same time, it is a bit tricky to figure out what actually is supposed to happen. Because we have like this return stuff handling, and this will try to print a ret instruction. We can take a look at what this does so you can see. So this thing essentially cleans up the stack reserve, and it does a bunch of funky stuff with patching stack arguments, but that's not what we want to do at all for the syscalls. I mean, maybe I can handle it here. So let's just do this weird thingy, and then I will figure out what would be the better way to make that happen. So folder return value and something like this. And in here, we would, yeah, the call convention. This is what I want to do. So we can say if literal has specified calling convention, and then if not calling convention, then calling convention is default calling convention. Okay, that I think makes sense, right? We either have an explicitly defined one, or we are falling back to the default. Seems reasonable. And now in here, we just need to do one more thing, which is push instruction, I guess. Push instruction, tag byte, no. Oh, that's not what I want. Eager, yeah, push eagerly encoded instruction. That's actually what I want. Push eagerly encoded instruction. Source range is whatever, we'll figure it out in a second. Builder, fine. And the instruction is syscall. So that thing that we look at the very beginning, this instruction that we defined, this is finally where we are calling it. Okay. Let's leave it like this, whatever, it's fine. All right, I think that's about it. See if it compiles. Yeah. Right. So that is a problem. Literal body. Legal interaction, yes. Source range. I don't have source range here. What can I use for the source range? Well, I guess I can use syscall body source range. Right, not this, this thing. Okay, different const qualifiers. That is not actually what happens. Sometimes C errors are really not what they say they are. And that I'm missing one more thing. We need to move into, yeah, so something like this. We need to say so storage syscall number storage is a storage register for descriptor. Let's clear out the whole thing. I mean, they say that it's passed in array X, which actually means that it is 64-bit. So maybe I was wrong on that thing. Yeah, let's change that while I remember. Let's make it S64 here. S64, and I think I need to change it here. Yeah, S64. I mean, technically that would work. It will just expand from 32 bits to 64, but it's fine. Here we need to say descriptor and S64, and it goes into register A. Okay, so we are moving to register A, and we are moving from immediate 32, which is syscall body number. Honestly, I can actually do it like this: S64 syscall number, and I will just say number. Okay. Is it the other way around again? Somehow I always mix up the order of this function, and this is immediate 64. Okay, well, that is something. I think I will open Visual Studio Code. Actually, no, that's a wrong way to open it, probably. No, it seems to be working even. I don't get why it always does that. Install the server every time. But anyway, what I want to do is I want to go back here, refocus on this test. And we need to build. And here we need to find the test. And in here, we can do a breakpoint. And then I think we should be able to step inside. But I'm not sure. The whole thing with assembly is a bit awkward in Linux debugging. Maybe we should maybe I should start it in GDB. GDB minus EX. I always forget how to do. Whatever. Let's just start it from here. It's fine. That is something else I was debugging. So we are here. And I always forget, is it this step? No. Somehow I never remember how to do it in GB. I know that if I press step into, I don't think I will end up where I think I want to end up. Yeah, it just doesn't do what I want. And it doesn't. Oh no, actually, look at that. It just worked. That is better than I thought. I would still like to look at the assembly, but apparently that's not happening. I need to remember how to deal with JGB, how to step through assembly. So, well, let's quickly Google that. Apologize for the light screen again. JDB, show assembly of, show assembly, show current assembly instruction, sounds about what I want. Layout, awesome. Okay, I think for that we will actually need to run it in GDB. I think it's something like break source spec C 20, something like this, I think. Okay, so that actually worked. Now I can do that layout awesome thing. Yeah. Okay. Step. Okay. So that was I think we need to restart it. Yeah. Kill it. Layout awesome. Is it like this? Yes, that is what I want, I guess. So si. So looking at the code, this is this stuff, and then it calls this function, and that function acts as a wrapper. So yeah, maybe the way I did it is not the best way, because ideally you would have a syscall right here. But I mean, it works, because now this will just yeah, this is definitely not great. So I ended up with a wrapper, and that's not necessarily what you would want, but it works. So we put the syscall number, so this 1, into arrayx as per calling convention, and previously you see that we are moving the size into, so this is E is the size of hello world, I believe. Here, yeah, so descriptor, buffer, and size, and this 1 into EDI is the one that comes from std out file number, and then this lia for RSI is for loading this buffer with hello world. So yeah, this is not perfect, but it works, which is way more than what we had when we started the video. I'm pretty happy with this. I still need to think about maybe a better way to support this, but yeah, now we have Linux Syscalls, which I think is pretty awesome. So thank you very much for watching. If you like this video, consider watching some of the other ones and maybe subscribing. And that's all I have for you for today. I see you next time. Goodbye.